us for this session on high performance computing and data science applications, collaboratively organized by the Department of Computer Science and Engineering and the Department of Computer Science and Engineering Data Science, CSD, at Vardhaman College of Engineering, Hyderabad. Our primary objectives for today's event are twofold: to enlighten and educate all the participants about the dynamic and ever evolving world of computing and data science applications, to guide our aspiring students towards building a strong foundation in this field, equipping them with the necessary knowledge and skills to explore the vast scope and promising opportunities in data science. I would like to extend a warm, cordial welcome to our esteemed CSC HOD Dr. K. Ramesh sir and CSD HOD Dr. G. Srinivasulu sir for providing this platform to enlighten in the computing and data science applications. Now it's a great honor to introduce our guest, Mr. Brajesh Kumar sir, who is an analytical and results driven professional with extensive experience impacting organizational performance through expert research and analysis. A curious analyst for data and visualization with 13 plus years of experience in an insight team with a strong hold on MS Excel, Tableau, Power BI, Python, R, and PL by SQL. Created a self serve dashboard for managers to improve the process in an organization. In the past, he did data analysis using Excel and Power BI for clients for operational improvement. Teaching experience in different colleges also he bagged. It's a great honor to introduce our Mr. Brajesh sir, who has completed his Bachelor Engineering in BITS Mestra, Ranchi from 2004 to 2008. Coming to his experience from 2019 to till date, he worked in platform provider company as analyzing issues raised by customers and presenting to BU's head for the better product experience, and also created a dashboard for different stockholders for process improvement. He worked from 2012 to 19 as lead value engineering at JDA Software Private Limited and 2008 to 2010 as assistant software engineer at TCS, and from 2010 to 2012 at IIM Indore. We are indeed fortunate to have Mr. Brajesh Kumar sir among us today, and we eagerly anticipate the wealth of knowledge and insights he is about to share. It is my hope that each one of you take full advantage of this valuable opportunity and gains substantial insights from his vast expertise. I would like to express my gratitude to all the participants for joining us on this enlightening journey into the realm of computing and data science platforms. Now, without further ado, I would like to hand over the session to you, sir. Brajesh, sir.
Yeah, thank you,
Yeah.
Nikla ma'am. That was very long introduction. Yeah, but thanks for that.
Thank you, sir. Please
So
go
I'm
ahead with your
sharing my
session, sir.
screen and let me know
Yeah,
if you can see my screen.
sure, sir.
So yeah, so what I thought that I will first start with my introduction and all, but you almost covered everything. So I don't think I need to cover anything. So as
Okay.
you mentioned that I'm working right now as a technical program manager in a ticketing tool company. It's a very big company. Employees are more than 25,000 and 10 billion revenue company. So it's a big company. I'm working there since last 5 years. And as you mentioned that I'm working in a way so that I can analyze the data raised by customer so that taking their feedback, taking their issues, analyzing all those data, trying to identify what are the trends, what are the root cause, and what can be the action item, which goes to the leadership team, and they talk with their dev team, support team, that how we can improve the process overall so that the customer in future they can't face similar kind of issues, or how we can make our product simple if it's complex. So in nutshell, these are the work I do as of now. Past work already you discussed about JDA, TCS and all. Regarding education, you already covered everything. I would like to highlight that I'm also doing PhD from Geetam Business School. I'm in almost completed second year there. So it's in process. Part time I'm doing there. Yes, MBA, B already did. I did certain certification from IIT, like it was 6 months course covering data science in our software and all. And you already mentioned the tools which I use during our work and all. Uh, almost I completed 14 years of research analytics, almost similar kind of work I was doing wherever I was in my previous. So in current organization, I'm working as a program manager. The work is data science. Before that, I was working in JDA software. There also I was working with data. The kind of data was different. That was like customer data. Here it's internal our data. So yeah, that is a difference. Already spent around 12 years in Hyderabad, and couple of papers got published in international journal like Green Supply Chain and Disruptive Supply Chain, which I presented, and it got published in international paper. So this is in brief. I don't want to discuss more. Already done a lot on that. So coming to our topic today, if you remember the yesterday's session where Sir explained everything, I think he covered very well, Alok Sharma sir, and it was very informative. I really liked the session yesterday, and it was challenge for me also that okay, the way he is doing session in different college and taking classes on that. So yes, I have to be in the similar fashion that I should provide more insightful information and all. So good evening, everyone, and thank you all for joining this session. We are diving into this exciting world of data science analysis, and we are using visualization by Python. So, as many of you already aware that Python is become one of the most popular language in data science. Everywhere you are in college, you are telling students, or students are coming that I said I want to learn Python and all, because this tool is very helpful, and it makes possible to analyze vast amount of data and visualize insights in a way that both accessible at the same time it's impactful. So, however, I mean, like given the vastness of this topic, it's important to set some expectation right at the outset. Like our session today is scheduled for about 2 hours and almost 15 minutes we already spent here. So, which is relatively short time to cover everything in very detail. And data science, it's a field that involves not only just understanding of data but also deriving insights, making decision based on those insights. So and a lot of things to cover like statistical analysis, machine learning, simple visualization to complex predictive modeling and all. So I will not explore every aspect in full details today, but what we will do that we will focus on fundamentals. We will try to understand what is the importance of data science. We will explore some key concept in data analytics and diving into how Python can leverage for powerful in visualization. And by the end of this session, obviously, you will have some foundation knowledge, clear understanding of why Python is go-to language in this field. And we will try to bring some practical examples so that you know how to use the tools and all. So let me get started, see how we can make sense of the data around us and using all those tools. This is the agenda I prepared. So what I'm going to cover that these all things we will cover in today's session, like what is data science. We will start by defining the data science and its roles in transforming data into actionable insights and all. Why data science is important? Because if you are talking about data science, then obviously we should talk about importance. We will discuss that the significance of data science in today's world and how it derives decision making and innovation. We will discuss about data analysis, like we will explore all the process of analyzing data to uncover patterns and insights, etc. We'll also try to discuss about the steps how we can make our decision better with the help of data. Visualization, why it is important when we are doing data analysis. So we will highlight the role of visualization in making data science comprehensible and actionable. And we will use Python for this visualization. So as I told first, we will discuss what is data science. So it's very simple. If we will bifurcate data and science, we know that data, how we are collecting data today. Everyone is talking about data. Just simple example that in your college, when some at the main gate, someone is entering, uh, means like security team is entering all the details who is entering as a guest, as a parents, teachers, every data is going in the system or in the notebook or file, whatever it is as of now. But yes, data is there. If you talk about any big gated community, they have different app, any visitors, any delivery boy, any guest, anyone is coming, they are taking data. A small thing coming to social media sites, like everywhere we are feeding our data, all the basic details, all our demographic information is going there. If we talk about all the important bank, IT, everywhere we are filling important information. So this you can understand that how data is there in the market. And the next part is science. Science is like we are using different methodology, statistics, computer science and all to analyze all those data. So by combining these two, we are talking about data science. So data science is nothing but it's art of transforming all this raw data into actionable insight, which we call it data-driven insight. And by leveraging tools like computer programming, predictive analysis, statistics, AI we are talking about these days a lot. So data scientists try to uncover all these trends, patterns, correlations in large data set. And this field is like multidisciplinary in nature, which allows us to address all the complex problem across industries. It's very difficult for human to bring insight from this huge large data set. We will go to that point also, how large the data is. So data science is nothing but empowering our informed decision through data-driven understanding. The importance, why data science is important. Just take any industry. I have highlighted here 6 industries, but you just take any industry. Data science is making impact. I'm talking about a simple example here. If I'm talking about finance, what we are doing in finance, like we are doing customer segmentation, like data science here, how it is helping, like it helps in different financial institution where they are categorizing the customers based on their spending habits. What is their financial behavior? What is their demographic? So what the data is telling, okay, these are all the data for any customer, and based on that this will enables personalized services. Like the call which I'm getting from a bank might be you are not getting, because they are categorizing us based on our spend, based on our habits and all, and they are giving us targeted market. It's like if I'm investing my money in mutual funds, they are suggesting us mutual funds. Someone is investing in stocks, they are suggesting in stocks. So they are making different groups, and based on that they are promoting there. So it's very targeted. And what will happen, it will like I don't want, means I'm a believer that mutual fund is good, so why I should spend my money on stocks? So if someone will call me, they will just waste their time. So it's important that which customer need which thing. Similarly, if you go to Amazon, if you are searching for any particular thing, it will suggest the similar thing. I'm booking a ticket from Amazon. The next promotion I will get that, hey, do you want cab from your house to aeroplane, airport? Or it will suggest that you are traveling to this particular city. These are the top 10 itinerary you can do. These are the top 10 hotels you can think. These are top 10 restaurant. So this is all targeted segmentation. They are targeting the customer, what they are doing. Based on that, they are suggesting all those things. Another thing like strategic decision making, like by analyzing this vast amount of data set, data science is helping in making informed strategic decision. And this can range from anything like investment strategy to optimizing operational efficiency. Next one is algorithmic trading. Like we know these days trading are very popular. Means like even students are in trading. So machine learning models, they are getting trained on this financial data to predict the market trends, automating trading, improve financial forecasting. Also, these all things are happening. And also the last one is risk analytics. Like this is very important. Like data science plays a very important role in risk analysis, like for banks, for financial institution. It's like they are giving the model which helps in like where the fraud can happen, what is the credit worthiness of the customer, and how they can mitigate the potential financial losses. So all these things are capable. So that's why I just gave you one industry example, but this is applicable throughout any industry you can take. Data science is making impact there. I will spend some time on this because a lot of information is there. This is like a picture, but if you see, it's from history to future in a common slide. So the left side, you can see the growth of data in 2020, 2013, when it was 4 zettabyte, the data was present, which was mentioned. And in 2020, it's 44 zettabyte. If you talk about zettabyte, then it's equal to 1 trillion gigabyte. So you can imagine how big the data is. It is equal to 1 billion terabytes. Means if I have to put the data in 1 TB hard disk, then I need 1 billion 1 terabyte hard disk to store 1 zettabyte of data. We have 44 zettabyte. So this is important data wise. A lot of data is now getting stored everywhere. Data is there. And now we are listening about internet of things, like we have a smartphone, we have mobile everywhere. Like data is getting, these are the tools where data is getting collected, source, like where the primary source where it is data is getting collected on my smartwatch. All my activities are getting collected on my mobile. All my social activities are getting on my laptop. Location, everything is getting collected. Then social media is there. There we are feeding a lot of data, and all these data are getting collected. So these data are getting collected, and it is helping in search engine. We can heard a lot now chat gpt and other gpt site. And because we have data, and these engines are using this data to predict future, they are suggesting something, innovation, whatnot. So this is the data growth and how the data science work in that. So there is a 5-step process. The first one is data gathering. I already discussed that how the data is getting collected. I talked about IoT, I talked about social media, other platform, and all data is getting collected. And when it is collected, it is getting a storage, store. And a storage is like how it is getting a stores. It's like it refers to any magnetic or optical or even mechanical media that records and preserve all this data, so that either ongoing project or in future we can utilize this. The third one is data mining. This is very important. This is the core of data science. Like data mining is like how we are getting the stored data to figure it out that what we have to do. So data mining is nothing but it's a process of using different statistical analysis or machine learning to discover hidden patterns which we human can't find. Are there any correlation? Are there anomalies within large data sets which we can't do? But yes, machine is there to do that. And this information will add in our decision making, predictive modeling, understanding complex phenomena and all. So there are different types of data mining. You might be very familiar with different, like we talked about clustering and classification. Both are very similar, but the difference is that clustering is simple with the common characteristic. It make cluster. It will make group with the common characteristic. Whereas classification is like it sort items into different categories based on the previously learned model. So I tell them, okay, if these are the characteristic, then put them. One is like they are highlighting similar characteristic and grouping it. Other, I am telling that, okay, these are the things. If it's present, then put them in group A, group B, and group C. Similarly, we know association, like if it identifies the pieces of data which are commonly found near each other. Like in marketing, if we talk about that, someone is going on Amazon or some sites where they have to buy something, and someone preferred, okay, I'm buying milk. Then the next thing coming in my list is, with this you can buy bread, you can buy other very similar biscuit or something like that. If I'm buying tea, then obviously biscuit or milk, something will come. So these are association. Regression is very common. Everyone knows about regression, that it's like to predict the numeric or continuous values based on the relationship between whatever the input value we are giving and what is the target variable. So regression is nothing but it try to find a mathematical function or model that best fit the data to make accurate predictions. Then anomaly detection, which we already discussed, like sometimes there are outliers. We have to identify some rare or unusual data uh, instances that deviates mostly from their expected pattern. And what is the use? Like it's very helpful in detecting fraudulent transaction, if there are any network intrusions or not, manufacturing defects, etc. And this anomaly detection is very important in IT industry these days, because we have seen how the fraudulent, how the fraud is going on. Lot of scams are going on, and chances of that security will be breached. So anomaly detection is very important. We do time series analysis, we do neural network, decision tree, text mining, and all. Not these are all part of data mining. The fourth one is analyze. So once we extract the data, we analyze it. Analyzing important because what data is giving and what you are analyzing, there should be a match. Data is telling something and our analysis is something else. So when we analyze as a professional, if I have to analyze something, then first I have to identify the problem statement, what I want to do. And I have to stick with that because data is C. I don't know how big the data, what are the information are coming, but I have to stick what is the problem statement which I want to solve. And based on that, I have to analyze the data. Otherwise, data will give thousands of information, thousands of observation. What you will do with that? What is important for you? Where you want to focus? If I'm analyzing my customer raised issue, then I have to think that, okay, I will target these three particular issues, then I will identify the root cause and then I will tell the action item. But if I'm going through the data, I have 50 types of issues. But with that, I have to give the priority that which kind of issues are prominent, which are very frequent, and all those. And I have to target. I'm not going to target the 100% of my data. I'm going to target only 50% or 60% where I can make most impact, because there will be a long tail. So I have to target that 20-80 rule, like 20% action item will impact 80% of the data, something like that. And then the data visualization. Why data? When I'm analyzing, then how data visualization is important. So there is a gap between a data analytics and the leadership team. Leadership team might be they are not as good in technical for this data. So data visualization is a tool which you can present to your leadership team who are non-technical, and they can understand the data in visualization format. So all these things are important. And yeah. And the last one, the right side, tools and methods. Like we know that when we analyze the data, we use statistics, artificial intelligence is there, we use mathematics, and where we use in practice, basically in cybersecurity, facial recognition, self-driving car, route planning, digital health, and all. So this is how data science looks like in nutshell. The pillars. So one very common myth is that if someone is doing data science in computer science and he is good, but that's not true. There are other domain and other pillars which are important to become a good data scientist. So you should have domain knowledge, you should have math skill, computer science, and communication skill. I will describe a little bit all. So domain knowledge is important because most of the people think that domain knowledge is not important in data science, but it is essential, because the objective of data science is to extract useful insights from the data so that it can be profitable to the company's business. And if you're not aware about the business side of the company, then how the business model will work for the company. So anyone can't build it better if you are presenting anything. So you have to know that what your company does, how the business is running, and which data is information is important. And as I was telling that you need to know how to ask the right question from the right people so that you can perceive the appropriate information. You know, need to obtain the information. And uh, I talked about the visualization. So one tool which I very frequently use is Tableau, which like it helps in displaying any valuable results or insights in a proper non-technical format, such as graphs, pie chart, that business people can easily understand. So if I'm talking about data and statistics, they will not understand. But same data, if I can present in some graph or pie chart, they can easily understand. Then math skill, we know that when we are talking about math skills. So when we are talking about all those things like in mathematics, data science is with nothing without a statistics and probability, algebra, multivariate calculus, all those things are important because it helps us in understanding various machine learning algorithm that plays an important role in data science. And statistics and probability, these are very important pillar for math skill. For computer science, everyone is aware a lot of language is there, a lot of visualization tools are there, supervised, must supervised learning, database, all these things are there a part of computer science. And the final thing is communication skill. Why it is important? Because it includes both verbal and written communication skill. And what will happen in data science project? Suppose if you are doing something in analysis. So the end goal is to present your data to some stakeholder. And sometimes this may be a report which you want to send to your boss or your team with whom you are working, or other time you want to present in a blog. So anything, regardless of where you are presenting. So a data science project always involves some form of communication, whatever the finding it is. So it's necessary that communication skill you have so that you can become a good data scientist. Now coming to our language, Python, that I already told in my introduction that this is the language of data science. Why? The reason is here, like it's simple, it's readable, it's powerful, it has powerful capabilities, and it has vast ecosystem of libraries and tool. So if you see that Python is the data science community, it's versatile and it can handle everything from data manipulation to machine learning. Integration wise, yes, it integrate with all other language and tools, and there is active community which always develops new libraries and framework. So all these makes data science, Python is important for data science. It's object oriented. If we talk about the structure supports, then it supports polymorphism, it supports operation overloading, it supports multiple inheritance and all. On top of that, it's free. Source code is easily accessible and it's powerful. Like if you want to do dynamic typing or built-in typing and tool, there are a lot of libraries. Even it can integrate easily with third-party utilities like Numeric, NumPy, and SciPy, etc. And it has automatic memory management also. And on top of that, it's portable. Like Python runs virtually on every major platform. So all these things making Python unique and more preferable than other languages in data science. There are you all know that there are different Python libraries and NumPy is very common. So if you see the right side, I have taken a screenshot of Colab, Google Colab. I use Google Colab. The reason behind is that it is a cloud-based machine learning platform that we can use anytime to write and execute Python code. I just need net, that's it. And I don't need to, it's free for most of the tasks. Like for other, I have to set up, I have to install and all, but here I don't have to do anything. Only I have to just open Google Colab on my system, that's it. And no setup required. Like I don't need to install any software on my computer, just create an account and use the web browser. I can easily share and edit my notebooks with other in real time. I'm sharing my notebook and you can edit, I can edit at the same time. Uh, because Google, the way they make their products, it's very usable, like Google Docs and all. It's very similar to Google Docs. I can easily access the hardware accelerator, like it's free access with GPU and TPUs, which can speed up my computation due to Google rather than a standard CPU, which is my local computer. And integration with Google Drive is very easy. Like you, I can easily integrate with my Google Drive and I can use it. So coming to the library like NumPy, we know that this is numerical operations and it is the foundation of numerical computing in Python. Very common, everyone use this, and it provides a support for arrays, matrices, many mathematical functions, making it very important for data science. Here I have written one code and I can show the Google Color thing which I was talking about. So this is simple. You can search Google Colab here, and you can create. You have to create your account. Just that it that's done. I can simple go file what I want to do. I have already some notebook. Then I can open upload. If I have to create a new notebook, simple click here, and just we are ready to do anything. So this suppose you want to, if I have to do some coding here, simple means like I have written some code. Simple. The first one was I was talking about. This is for multiple simple multiplication. Like I am putting all the numbers in an array, and then I want a simple multiplication. It's nothing simple. You just put the code and run it. It will give you the result in. So this is the first time I'm running today, so it is taking time, but generally it doesn't take that much time. So once this will run, then yeah, you can see the result here. I simple gave the number in array and it just calculated simple way. And the UI, I like it. Here means like all the details which you can see. This is one where input output at the same time I can see rather than different portion is there, and it will all explain. There are AI inbuilt in that. That is another feature. If I'm doing something wrong, so it will give me something at that moment only that. So I can see everything that I have taken some character rather than number. It will explain that what is happened. If I want to explain the error, then it will give me that what I have not defined properly, and that's why the error is coming. It will also suggest me what I can do. So this Gemini is nothing but the AI from Google. It is not just telling me the error, but it can show me that what I can do. Like it is telling me that okay, in place of a, just mark number one, give the number one for a, and then run it. So either I can take the code from here or simply I can change it as one, and I'm done. So that's why I like Colab. So you can use anything, Jupyter notebook and all, but I prefer this one. This is very user friendly and all. So this was one example for NumPy. And this is another library like pandas. This is also very common. This is for data manipulation analysis. Like Panda is the go-to library for data manipulation. And it allows me to load any data, manipulate that, analyze data with minimal code. Means code is, you can see that I have taken one link here, URL. I'm directly retrieving the data from the link, and I can read it and then I can print it. So you can see if I will run this code, then this kind of result will come. So this is like one data set of wine quality, and it is giving me just a gist that what are the in data is there in the data set. Then if I have to plot a chart on the data set, then I have to define it that, okay, what I want to do, how I want to manipulate. So I have to create a bar chart here, and it is like the code I have written with the library as matplotlib. This library helps in creating different kinds of graph, and with the like the data set was of wine quality. I want to call one count the quality rating, so different ratings are there and how much count is there based on that, and I can define it here. The best part is that what is the title, I'm defining it, what is the x level, what is the I level, y level, everything I'm defining here. And it is simple, it's very simple, and I want to show this whatever the definition I have given this for library, I'm trying to give it. So this is helpful, very easy to use. And apart from that, these are other libraries which are very common, not limited to this, but a lot of other libraries are there. But these are like NumPy, we already discussed, Matplotlib, Pandas we discussed. Other are scikit-learn, like this scikit-learn is, yesterday sir was also mentioning this scikit-learn, which offers simple and efficient tool for data mining analysis. Like it has built-in algorithm for classification, regression, clustering, and many more. Similarly, Keras is there. It is nothing but it's written in Python only and capable of running on this TensorFlow, which is like uh, TensorFlow where Facebook uses and for deep learning and all. SciPy is there. SciPy is open source Python library used for scientific and technical computing. So it provides modules for optimization, integration, interpolation, and all other advanced computation. TensorFlow we discussed, that is like developed by Google. It's also very powerful, and it's open source for deep learning framework that allows developers to build and train machine learning models. And it's highly scalable and used in variety of artificial intelligence applications. PyTorch, like it is developed by Google, PyTorch developed by uh, Facebook as their AI research lab. It offers dynamic computational graphs and very widely used for research in production of deep learning thing. C1 is nothing but it's like Python data visualization library is there based on Matplotlib. So this is based on this one, and it provides a very high level interface for drawing attractive and informative statistical graph. So I brought the very common one. There are more, but yes, these are commonly used. Now coming to our second topic, which is data analysis. So we already discussed about data science. Now data analysis is other part of data science. We have data, then we have to analyze it. Today we know that data is being collected at every corner of the street, and with every click on the touch pad we are doing for various businesses and website, we are giving data. So analytics refines all this data and derives meaningful information such as like what does a customer need, what's the fastest shipping route for product delivery, even like something like big socioeconomic issues like how did the COVID lockdown affect the overall climate and all. So if I have to put in simple word, then if data is the new oil, then analytics is the refinery. And data analysis or data analytics, like it involves the process of studying, cleaning, modeling, and transforming this data to uncover all the actionable insight. We can suggest conclusions and support informed decision making. This is very important for optimizing business performance. By making better decision, we can identify the customer trend and also improve products and services. When we integrate it with our business model, data analytics helps organization in reducing their cost by discovering some more efficient operational method. So ultimately, this derives innovation and competitive advantage. Every company, if you see, they're talking about data. Gen AI, artificial, these are very common word. So companies are selling their product that, hey, my product is AI enabled. So this way they are trying to differentiate themselves. Every colleges are like, we are teaching data science, artificial intelligence. Earlier we know only computer science. as a branch, but now under computer science there are sub branches are there. So it's now everyone knows the importance of data science, and we have demand, and we are going to supply from the college level. A lot of institutions are there where they are providing certification. All big colleges, they are providing some sort of certification in data science and artificial intelligence. So we can understand why data analysis is important. Now coming to the data analysis, that how the data analysis flow works. So this is real world from where we collect the data, and then we process the data. After processing, like we clean it. That is very important because the data which we, it's a junk, and we have to clean it. So a lot of data is there. If you go to the retail chain, many people are not giving the correct data. So we have to identify with the statistical model. We have to clean the data. We have to treat the blanks. We have to treat some anomalies. We have to treat outliers, and we have to clean the data. Based on that, only we can either do exploratory data analysis, or we can create models and algorithm, which will help in again collecting the data and either communication with the report, and based on that we can make decision. Now this is the flow chart of data analysis. Next one is application of data analysis. So you can see the way we talked about data science, the similar way it's data analysis. All the important industry as we are doing data analysis, like if we talk about like customer acquisition and retention, like for any business, customer is god, and all marketing, all innovation efforts circle around what the customer needs. So in today's very competitive market, and acquiring customer is very tough because customer have a lot of option. If I have Uber, then I have Ola also, and they are local thing also. If I have Amazon, then I have other Flipkart and outside. So we have a lot of action companies which are providing me similar kind of services or products. So it's very tough nut to crack for companies. So add to that the ever-changing behavior and purchasing patterns for the new age customer, we can, which we quickly influence. If someone is giving me 2 rupees discount, I will go to that. So I have a lot of power as a customer. So how should a company reach out to new customers while balancing their marketing spends? So big data analytics is there, and it allows businesses to keep a track of customer related patterns, and delivers the useful insights, like what's the best target audience for the particular product based on location, based on age group, financial classification. Such examples I already gave at the start. And what are the channels, like how they should target the customer? It should be, sorry. So channel is also important, like for young age, all those they are going through a social media sites, so there they can, like now you can see if someone is opening Facebook, Instagram, they are getting ads. Even for old age people, they are watching TVs, there are ads in everything. So where to target? If they are giving any, Ramayana serial is going on and they are promoting any very what I say, digital thing, very recent, it's like recent innovation and all, though those are not the right people. I think Ramayan, like people at the medium age or old age, there these people are watching. For them the product, marketing products should be different, the ads should be different than the person who are using Facebook, Insta and all. So these are the channels, and what is the frequency and all, everything is important there. So couple of examples, like if I talk about Walmart, everyone I hope Wal knows the Walmart. It is one of the biggest retail chain and in the world, and it launched Walmart Lab to empower their big data analytics and fuel its growth. So they started one program which called the loyalty program, and that was the first initiative designed by Walmart for customer retention. So customer retention is important. Then bringing a new customer, a customer, if someone already bought, how I can make them loyal. So they started a program called Walmart Plus, where the charges, $98 annually per customer and offers benefits like unlimited free delivery, scan and go shopping features, fuel discounts. These are the few. And they also use predictive analysis to forecast like how many their 500 products should be there, like which location are selling which product more. And in that way, they are making it more efficient and convenient for their logistic and offline retailing. As a result, the customer acquisition and retention say the company has tripled their sales from 21.9 billion in 2019 to 64 billion. So triple their online sales from these all kind of this information which was possible with big data analytics. Other thing is risk detection, like many companies do risk detection, that what kind of banks and financial organizations are there. They should bring some mechanism so that it could rescue them from losses incurred with fraud customers and bad debits. We talk about NPA in our banking system. We talk about credit defaulter and all. So these are the things which they can use with data analysis, that how they can avoid this. Then we have one example was that very important, like we used in COVID time, like how data analytics helped the world to fight the COVID. So we all know that how COVID-19 has had a huge impact on the world. But it could have been more catastrophic effect if there was no big data analytics in the healthcare industry. Like all the stakeholders, including healthcare professionals, lawmakers, researchers, turn to data analytics and predictive modeling in order to help their like distribute resources so that they can optimize patient care services and apply preventive measures all across. So all these tools, thanks to all these tools mentioned above, the data keeps coming at a constant rate, allowing for a better understanding of the patient's symptoms and how to respond to them. So if you were in India at that time, you must have downloaded the Arogya Setu app, if you are aware, on your phone to detect any threat of infection. So just imagine how beautiful it was. Like I have Arogya Setu app. I know which area is impacted, which are red zone, which is orange zone, which is green zone. And it was helping in making decision. Also, the time when oxygen cylinder was in a scarcity, then this data analysis, like where you can get which hospital, how far it is, everything was there. Everyone was developing some tool to help the to go to get a common benefit to get rid of this COVID and all. And so you can just imagine that how beautiful data analysis and data science is there in healthcare segment. And yesterday, sir also mentioned the same thing, that how cancer detection and all at the earliest stage without any physical presence and all. So these are the benefits of things. Now, I will touch a little bit of Internet of Things. Like we know that these days we are using a lot of Internet of Things, like sensor data from these devices, my mobile, my smartphone, smartwatch, computer, everything is taking data. And this data is getting stored, then getting analytics is happening. And based on that, we are using data monitoring and applications. The Google, if you heard very recently that Apple Watch saved good number of people from heart attack because it detect early and it send the message to the relative or the close one that has something happened to this person, either they met with accident or some heart attack or something like that. So these are the things, if we think in positive way, they are making good impact. So this IoT refers to the network of physical objects that uses sensors, software, and other technology to connect and exchange data with other devices over the internet. And these are like thermostat, smart lights, refrigerator, smartwatch, all sort of large scale industrial devices such as cars, pipelines, weather stations, everything under IoT is there. And all these devices have good number of sensors to collect the data, which are then analyzing it. So this is important. One screenshot I have taken for like how Tesla uses this IoT analytics. So one person named Simons, that he posted this tweet in 2017 that Hey Elon Musk, surely I'm not the first to suggest this, but it would be cool to get in my car and ask it to take me somewhere. So at that time, he mentioned this that I want some car that driver is not there. I will just simply tell to car that go somewhere and it will go. Elon Musk replied that it won't even need to ask you most of the time. And as promised, Tesla has set up an exclusive range of self-driving cars that converting the fantasy into reality. And how does this work? That's where IoT analytics comes into picture. Like these vehicle process vision, sound, radar data using these devices, and when the car pass each other, they share data which then analyze again to decide the correct path, the traffic, and other things. So this is how IoT is working. Okay, so data science, data analysis, and now visualization. So we talked about very basic, then analysis part, and then how to present that with chart and graph selection. So here you can see that different charts are there and data visualization. I know that this is the process of creating all those graphical representation into an information. And this process helps the presenter that how we can communicate with other stakeholder, what we want to say, what are the story we are going to make, and these are the different pie chart, not these are different chart, not limited to this 10, but a lot of more charts we can bring with our visualization tool. So data visualization thing is that why we do. So we have to visualize to analyze. If you see that different data is there, and with that we can create different chart, but what is there, we should visualize that what we want to analyze. Are we analyzing any pattern? Are we analyzing any correlation? Are we analyzing any trends? All those things are there. So the data should be like that, that use visual tools like charts and graphs to break down the complex data, revealing their patterns and trends that will help in decision making and insight generation. What data will do? It will visualize to discover. So, and at first analyze and discover what I want to find. Like exploratory visualization will allow me to uncover all the hidden relationship and insights within your data that might not be obvious in the raw data. Like I can't say by looking at the data, I can't visualize that what can I discover. But with data visualization tool, we can easily discover what is the relationship, how it looks like, which is big, which is small, which part of the country, everything. Like how you want to slice and dice, it depends on you. So visualize to discover, visualize to support your story. Suppose you have to create one story for a leadership team. The data will support you for your story. It will give you the clear picture what you want to see. Here in the graph I can see that for for country wise, what is the income for poor and rich? You can see the left side is poor country, the right side is rich country. And it's easy to make a story that what I want to say. Easy to read, color wise, everything is discussed here, like what is the health and income of the nations in 2013. And story wise, it's very clear. Then visualize to teach. So visualization simplify all the complex concepts, making it very easy for learners to grasp and retain the information. And as the picture says that 90% of the data or information transmitted to the brain is visual, and 20% sensory receptor in our eyes, 50% of brain is active, and 40% people respond better to visuals. If we have visuals, then it will be a great enhancing in educational experience and other information. Now the other part is that, as I mentioned, that there are a couple of charts or something which we can discuss. So I have considered here one chart like World Happiness Report, and data set provide inside the happiness score of the countries. Uh, so let me bring my, okay. So this is my Google Colab, and so simply So let me bring the COVID data. So this is like I'm importing with pandas and I have the COVID-19. This is one of my favorite data source and which I import from GitHub. And you can see that how I am going to read the data from CSV file and I want to check that how the data looks like. So this is just in nutshell, it is showing that what all countries are there, how many confirmed cases, recovered and deaths. These are the benefit of Collab, which I think that if I want to analyze more, it will give me all those like categorical distribution, time series. So more thing I can do with using the AI stuff here. And so the data is already got uploaded here. Now I have to see that how these datas are working and if I have to play with the data here, which I was showing you, you can see in the graph here that this is my COVID data set, the country wise, and uh, it has the data for all the cases of confirmed deaths and all. And this will display my data in so let me bring some chart here. I want to bring so that how the month wise and week wise the data was going for these cases. So I'm doing a seaborne and my this is my chart library. I want to define by country that how the country wise data is there. For India, I want to check and I want in line plot and label I can give it here as I told and I want in grid format. So if I run this data, let's see the output. So you can see the graph where this is week. The X bar is not visible week by data, but this is the chart we can see through 2021-22 data. And we can see how many confirmed cases were there date wise. We can see that earlier it was very stagnant, then again it started, and in between two times it went very fast. So this is how we can analyze data, the time series. It is showing me that data how to read and all. So you can see here that the trend is showing for confirmed cases over time for a specific country. Here I choose country India because I have to show this. Otherwise I could have chosen other country and it will show the same chart. And the chart here I use is line chart. And we know that this is best for showing the data trends over time. Here my time was 2021 time frame. And we were trying to track the number of incident happened. And what are the benefits of using the line chart? Like it's allows for easy visualization of trends, such as what were the rise when the fall happens of cases over days, week, and months. And it will help me in identify the peak, surge, and declines in the cases. And this is very important to understand. With that, when I was telling that during the COVID time, data science and data analysis was happening, people are observing such kind of graphs so that it was easy that, okay, which country is having more number of cases, where to focus. Here it's country, then I have to go by district wise where we need more focus, more strict action should be like. Uh, we know that during COVID time, some states were least impacted, some states were more impacted, where we need more strict action and all. So all these things we can have gone through this line chart. Now coming to the next, this is bar chart, the same data set. I want to see that how many number of confirmed cases came country wise. What is the country tally wise? If you see, so this is the data set which I then, so we bring it here again. So I want to create a bar chart for all those countries in top order. And so this is the graph which is showing my that okay, these are the top 10 countries by confirmed cases. If someone was thinking about traveling after some time, then they could have seen this graph and could have taken their decision that they should travel those country or not. So most impacted were US, then India, Brazil, and all. So visualization is important. Means I can't explain everyone that okay, how the data looks like, but with the graph easily I can show them that what is happening there. It is showing me that total number of confirmed cases by countries on a specific date. And this bar chart is like this is ideal if we want to compare the discrete categories or groups. Like example, if I have to say that comparing the number of incident across different regions, and it provides a clear comparison between different groups, like making it easy to see which category stands out. So compared to the total number of COVID-19 cases across different countries or state, so pie chart was this bar chart was very effective for comparing quantities across different categories such as different regions, and it was allowing for clear comparison. And so here there are top 10 countries, but if want to see bottom 10, then also we can check that. The next one is like I want to show the proportion of the confirmed cases by continent. So I know, okay, country wise I have the data. What about the continent? So for that, what I have to do that I have to, my data was in country format. So I have to discuss and I have to make our massage my data that it should bring continent also. So I have to define that which countries are in which continent and all. So what I can do that, okay, I will put, I have taken some countries and I'm putting it in continent. So if China is there, then put in Asia. If United States, North America, India, something like that I'm doing. I have not done for all. And with that, I want to plot it in pie chart, that continent wise. If you see here that because I have given very limited number of countries attached with the continent, that's why this other part in the pie chart is very high. So Europe has 21.2, Asia is this, South America is this. So this is the data. It shows like if we discuss about our pie chart importance, then this is useful for showing the whole part. When I am taking all data which I have available, and it is giving me the percentage of different types of continent and how many cases are there. And in my original data set there were no continent, but very easily I can map it. Even I mapped 40% only, but I mapped it in the similar way. If there will be supervised learning, then and I can tell that okay, based on this you can do unsupervised learning, put all those things, or I can bring the map also. So I can link the map here and it will automatically take the countries and it will connect with the continent with that. So this is like distribution of different outcomes. I want to say like what are the different continents are considering different patient and all, and it provides a clear and simple way to visualize the proportion, and it always cover 100%. And here this pie chart is showing the percentage of total COVID-19 cases that resulted in recovery dates and is still active. Everything it confirmed. My next slide is on histogram. That is also important where I want to see the distribution of confirmed cases across all countries. So what is the distribution? Well, how many confirmed cases are there and how many countries are there for these confirmed cases? So if I do, so I'm showing here the example. It's easy. That's why I'm showing in Collab. And also once you will start preparation or the practicing, then it will give you some. I will share all the examples with you. So you can see these are the confirmed cases on the x-axis, 1, 2, 3, how many confirmed cases are there and how many countries are there which have confirmed cases. And here it is showing that in distribution format, which is like 0 to 1. I can see the graph is very big. A lot of countries are there. Here 8 is there. So easily I can, with histogram, I can get the distribution. So this histogram is very suitable if we have to visualize the distribution of single variable. Here I want to see that what is the distribution for that. And suppose if I'm talking about to understand the distribution and spread of data, such like I want to identify which groups are more affected by the virus and all. So I am targeting one particular, like which group, age group and all. So this is helpful in those distribution. And the histogram here is showing like number of COVID-19 deaths across the different age group. So this is histogram. Then we have a scatter plot, and you know that scatter plots, it shows the relationship. I want to show the relationship between the confirmed cases and deaths. A scatter plot are important when we have x-axis, y-axis data, and we want to see outliers. We want to see where the maximum occurrence is happening. So we just downloaded, we are loading the data set there, and so now I need to do the scatter plot. And this, you can see that I want check all the confirmed cases and how many deaths are there on y-axis. So these are the confirmed cases which COVID happened and how many deaths happen on the percentage wise. So here, like one death case, what is the percentage in that? How many are 50% or 40% confirmed cases are there? What is the death percentage? So we try to correlate, and these are the data is based on the dates, and we what we do that with a scatter plot, like it's best for exploring between the two continuous variables, like one is going through the cases, one is going through the dates and all, like accessing the relationship between incident and casualty is happening. So this is great if we have to identify the correlation, we have to identify the patterns or potential cause and effect relationship between two variables. If I have to check, then this is very important there. And like what we are doing here, that we are trying to find relationship between number of COVID-19 tests conducted on confirmed cases in different countries. And this is useful in correlation, trends, finding the outliers between two variables. So you can see there are some outlier. Most of the data is here, and there are some outlier, and one you can see here. So this is like if in other cases we have to find anomalies and all, then this kind of a scatter plot is really helpful. So a scatter plot nothing but it's trying to show the relationship between the number of tests conducted and confirmed cases in various countries. And this one is heat map, like we want to show the correlationship between different variables such as number of incident, casualties, and how many wounded are there. So this is showing that the heat map is very important because it's easy to understand where the problem is. So in this example, we can see that how many confirmed cases are there, how many deaths are there, how many recoveries are there. All these things are we are checking here. And if we have to see on the graph, so this is for heat map. I'm taking all those confirmed deaths and recovered cases, trying to correlate, and then checking the heat map. So you can see that where this red is there, there is the concerned area. So how many recovered, and so you have to define that how it is happening. So it is showing the correlation between confirmed cases, deaths, and recoveries. So if we see in our the PPT here, and so this is an effective way for displaying what is the intensity of the data in matrix format. Like suppose we have to find the correlation between different factor like incident, casualties, and wound. In this case, confirmed death and recovered cases. And it provides a very comprehensive view of complex data. Like in my case, when I analyze my data, I have to check that I got suppose 50 type of issues. With 50 type of issues, probably I would have link how many cases are there. Suppose for 50, I have 1000 data. There are 50 issues. This 1000 data will link with all these issues. With the heat map, I can show that which issues are prominent. Or in my company, there are different business area. Under that, different uh, applications are there. So which applications have more number of customer cases are coming? I can easily show them in heat map that these are the area where a lot of cases are coming. These are the application where a lot of cases are coming. So I can easily tell them that, hey, these are the application where you need some action item because these are dark, the light part. Also, in if I'm talking about financial term, then if it's red, then it's not good, and it's green, like lower value than green, and darker red value is red. In the heat map, I can easily show that where to focus. So for leadership team, this is one of the most useful chart because it shows the intensity of the data. And here, like when we talked about the COVID-19 example, like it shows the correlation between the various factors like cases, deaths, hospitalization, and ICU admissions, everything in different regions. It will allow me to quickly identify the patterns, correlation, and hotspots. And sometimes in Arogya Setu app, it was also showing that nearby area, which area is red, which area is light green, and all. So this is showing all those different COVID metrics across the state and on the thing. So I kept all this chart. There are more. This is very basic chart which you can easily use, but not limited to this. There are multiple chart, and Python is very strong tool where you can do a lot of things by calling the libraries, Cburn, and also you can do a lot of things. So this is all I put in the session today. Here early might be I went very fast, but we are open for questions, and I will take that question. So, how was the session, and what all questions you get? What more you want if we have any next session, and also there are.
Any questions, please ask. Dear participants,
If anyone is having any questions, please unmute yourself and you can ask.
So my mail ID is there. If you have any further question, also, means once I will share my PPT and example, anytime you can mail me, I will take care of that. But so.
Shanti ma'am?
yes, ma'am. I think no questions are from there.
Yes, yes.
So either it was very good or might be no one understood anything. So yeah.
No, sir, obviously it is very good. Uh,
Ma'am,
shall we
continue.
go with, yeah, shall we
Uh,
go with vote of thanks, ma'am?
yes.
Okay. It is with great honor and privilege that I address you all today during this remarkable session. I would like to express my deepest gratitude to Mr. Brajesh Kumar sir for graciously dedicating their valuable time to conduct these special sessions, which have undoubtedly enriched the knowledge and awareness of numerous individuals in the field of data structures. I would also like to extend my heartfelt appreciation to our esteemed management, beloved Principal Dr. JBR Ravindra sir, HOD of CSC Dr. K. Ramesh sir, HOD of CSD Dr. G. Srinivasulu sir for their support. Their guidance has been instrumental in forecasting an environment conducive to the expansion of data structures applications. I would like to thank the faculty coordinator, Dr. Shanti Makka ma'am, coordinators, co-coordinators, organizing teams, and faculty members of the CSE and CSD departments for organizing such a wonderful session today. Lastly, I would like to express my sincere gratitude to every participant for their interest and active engagement in the data structures applications. Your enthusiasm and dedication have contributed significantly to the success of this event. Once again, thank you very much, sir, to those who were involved directly and indirectly in organizing this event. Thank you. I would like to invite Dr. Shanti Makka ma'am to brief the participants about the tomorrow's session. Shanti
Thank
ma'am.
you, ma'am. Yeah, ma'am. Thank you so much, ma'am. Rajesh sir, once again,